Okay, so for the option pricing, I've started out with some information for BBT stock, or BBNT, ticker BBT. I've downloaded price data and adjusted close data. You'll see the formula for the value of the call, which we're going to employ in a second. Went to Yahoo Finance, downloaded 1 year of data, and went to NASDAQ to get the option chain for BBT. Going to look at the pricing of the September call with a strike price of 50. We see that the bid and ask are 320 and 350, so the midpoint is 335, which is great because that was the last price actually in the marketplace. So we're going to look at the implied volatility and see how our pricing compares. Also, before we continue, went to U.S. Treasury and got the 1 year Treasury bill rate, 2.56%. That's what we'll be using in building this model up. Okay, so again, the current price I just used is the last of close today. The strike price of 50. We're interested in the call that expires on September 20th of this year, or 2019. The risk-free rate is 2.56%. To calculate time, we're going to use the formula as equal to the date in the future less today. And then what we'll do is put this number in parentheses and divide by 365. Lastly, we need to tell Excel that this is a number. So we can see it's 0.59 years remaining. We're going to calculate the volatility by first taking the natural log of daily returns. So we'll divide today by the prior day. And in any given year, there's going to be either 250 or 252 trading days. So notice we start in row 2. If we go all the way down, we see it's going to be 250. I'm just filling in the returns. So those are our returns daily. So again, it's just the log of today divided by the log of yesterday. We then need to calculate the standard deviation. So used for the population. So this is the daily standard deviation. And so hopefully you see this really low number here. And you're thinking, wow, that sounds a little bit low. You think, well, it might be a bank, so the volatility is low, but this is our daily standard deviation, and we need to annualize. So to annualize, it's going to be equal to this number times the square root of 250. So our volatility is right there. So now we can solve for D1 and D2. Again, this is just simply plugging in numbers. Price divided by the strike. The risk-free plus the volatility, power of 2 divided by 2 times time divided by volatility times square root of time. To calculate D2, D1 minus volatility times square root of time. Now we need to take norms dist D1, and we're going to do the same for D2. Now we'll calculate the value of the call, which is equal to price times D1, D1 minus the strike times the exponent, the negative risk-free, times time, times n of D2. So what we see is, given our inputs here, this call should sell for $4.03, and it's actually selling for $3.35, which means it's surprisingly underpriced relative to the market. It's a rather cheap option. So what we can then do is also calculate the value of the put, which is equal to the value of the call plus the price, minus the price plus the strike times the negative risk-free times time and so the put should be selling for $2.60. So if we go back to the option chain, we see the put is also, well, correctly priced, but for some reason the calls are relatively cheap for BBT. Now the one thing to mention is this is a dividend paying stock, and so the Gordon growth doesn't do well, or doesn't price well when dividends are being paid, so we have to take that into account. That's possibly